This is Physics, Chapter 7, Circular Motion. This is the schedule for this unit. We're going to finish up the egg drop project on Monday and Tuesday, 9th and 10th. Circular motion will be done on the 11th and 12th. Circular motion lab will be done on the 13th and 16th. Universal gravitation will be finished up on the 17th and 18th. Torque on the 19th and 20th. 2 review days on the 23rd and 24th, and the Chapter 7 test on the 25th and 26th. Lesson outline. What is circular motion? And the in-class work is going to be assigned questions from practice 7A and 7B. Make sure you read through 7.1 and 7.2, watch the 7.1 screencast and the 2 YouTube videos, and take the practice quiz. Learning targets include: I can solve problems involving centripetal acceleration, I can solve problems involving centripetal force, I can explain how the apparent existence of an outward force in circular motion can be explained as inertia resisting the centripetal force. This is the YouTube video, and it's the effects of a circular motion on a hungry squirrel. I will post this on Sophia as a separate YouTube video. Circular motion terms. The point or line that is the center of the circle is the axis of rotation. If the axis of rotation is inside the object is rotating or spinning. If the axis, on the other hand, is outside the object is revolving. So the Earth rotating is the axis being inside the object. The Earth going around the Sun is considered a revolution or revolving. Objects move in a circle still have a linear velocity which is equal to distance divided by time. This is often called tangential velocity since the direction of the linear velocity is tangent to the circle. Objects moving in a circle also have rotational or angular velocity, which is the rate of angular position changes. Rotational velocity is measured in degrees per second, rotations per minute, etc. Common symbol for this value is the Greek letter omega. So the rotational velocity is equal to the change in angle divided by the time. If an object is rotating, all points on the object have the same rotational or angular velocity. All points on the object do not have the same linear or tangential velocity. Linear velocity of a point depends on, number 1, the rotational velocity of the point. More rotational velocity means more linear velocity. The distance from point to the axis of the rotation. More distance from the axis means more linear velocity. Rotational and linear velocity in symbols. V is velocity, R is radius, and omega is the angular velocity. Acceleration speeds up, slows down, or changes direction. As an object moves around a circle, its direction of motion is constantly changing. Therefore, its velocity is changing. Therefore, an object moving in a circle is constantly accelerating. Acceleration of an object in a circle points towards the center of the circle. This is called centripetal, center-pointing acceleration. Centripetal acceleration depends on the speed of an object and the radius of the circle. You're going to take a bowling ball and see if you can get it going around in a circle. These are the instructions. Newton's second law says that if an object is accelerating, there must be a net force on it. For an object moving in a circle, this is called the centripetal force. The centripetal force points towards the center of the circle. In order to make an object revolve about an axis, the net force on the object must pull it towards the center of the circle. This force is called the centripetal or center-seeking force. Centripetal forces on an object depend on the object's mass. The more mass means more force. The object's speed, More speed means more force, and the object's distance from the axis or the radius. If linear velocity is held constant, more distance requires less force. If the rotational velocity is more constant, more distance requires more force. So the force, centrifugal is the force, m is mass, velocity is v, r is radius, and omega is the rotational velocity. I made a minor mistake on this. Omega in this slide should have been also rotational velocity. Work done by centripetal force. Work, remember, is equal to force times distance times cosine theta. Since the centripetal force of an object is always perpendicular to the object's velocity, the centripetal force never does any work on the object. No energy is transformed. Centrifugal force is a fictitious force. It is not an interaction between two objects and therefore not a real force. Nothing pulls an object away from the center of the circle. What is erroneously attributed to centrifugal force, centrifugal force is actually the action of the object's inertia. Whatever velocity it has, it wants to keep. Homework again is to read Chapter 7 and 7.2, watch the 7.1 screencast, the 2 YouTube videos, and take the practice quiz.